Let's talk about your digital life for a second. All your messages, your photos, your private documents, all of that, it's treasure. And just like any treasure, you need a fortress to protect it from prying eyes. So today, we're going to dive into how to build that digital fortress using the power of data encryption. This really gets to the heart of it. We're not just talking about some abstract lines of code here. We are literally stepping into the high-security vault that protects our entire digital world. This is where the most valuable secrets are kept and, well, the whole system really depends on getting this right. So at its core, encryption is the main wall of our digital fortress. It's basically the art of taking perfectly good information, your data, and scrambling it into a meaningless puzzle that no one, and I mean no one, can solve without the right secret. And here's something that's absolutely crucial to understand. Our data isn't just in one place. It needs protection everywhere. When it's just sitting still on your hard drive, that's data at rest. When it's flying across the internet in an email, it's in transit. And even when it's being actively worked on by your computer's processor, it's in use. It has to be shielded in all of these states, no exceptions. All right, so how do we start building this fortress? Well, we start with the simplest, most direct form of protection out there. A single, powerful lock that does one job and does it extremely well. This is our first, most fundamental line of defense. This lock is called symmetric encryption. And the idea behind it is, well, it's wonderfully simple. You have one secret key. That key locks the data, and that very same key unlocks it. Think of it like a diary that has a little physical key. As long as you're the only person with that key, your secrets are totally safe. And because it's so darn efficient, it's perfect for locking up huge amounts of data really, really fast. And the process itself is just beautifully straightforward. You start with your plain text message. Let's just say hello. You apply the secret key and poof, out comes a string of complete nonsense. We call that ciphertext. Now, the only way to turn that jumbled mess back into hello is to use the exact same key. It's simple, it's effective, and it is incredibly secure. Now, these aren't just some theoretical ideas. These are the powerful algorithms running our digital world right now. AES, the Advanced Encryption Standard, is the undisputed champion. It's a total workhorse that's been proven for decades and is probably securing your Wi-Fi connection as we speak. Then you have newer algorithms like Cha-Cha-20, which are designed to be extremely fast and efficient, making them perfect for, say, the phones in our pockets. Just think of them as the big brand names of our digital locks. Okay, but this brings us to a huge, critical problem. That diary key is great if you're the only one who ever needs it. But what happens if you need to send a secret message to a friend across the world? How do you get them a copy of the key securely? I mean, if you just send it over the internet, an attacker could just grab it, right? And then your whole fortress is completely useless. This is the central challenge that we have to solve. And the solution to that problem? Oh, it is nothing short of elegant. Instead of one key, we're going to introduce a system that uses two keys. It's this clever little dance that completely changes the game of secure communication. So this system gives you two keys that are mathematically linked together. The first is your public key. Think of this as an open mailbox slot. You can shout this key from the rooftops, post it on your website, anyone can have it. They use this key to put messages into your mailbox. But the second key, the private key, that's the one you never, ever, ever share. It's the only key in the world that can open that mailbox and read what's inside. And right there, that is the magic of asymmetric encryption. The public key locks, and only the corresponding private key can unlock. It's a one-way street. So your friend can use your public key to encrypt a message, and they can be totally confident that you are the only person in the world who can decrypt it with your private key. And just like that, the key sharing problem is solved. But here's the real kicker. In the real world, we don't actually choose one or the other. We use both in this beautiful hybrid system. Remember how we said symmetric encryption was really, really fast? Well, we still want that speed. So what we do is we use the slower two-key asymmetric system for one tiny little job, to safely exchange the single fast symmetric key. Once that's securely shared, we switch right back to the fast key for the rest of the conversation. Pretty clever, right? Okay, so we've built our fortress. We've got these incredible locks. But a fortress is only as strong as the people who hold the keys. The encryption algorithms themselves, they're rock solid. The real challenge, the place where things almost always go wrong, is managing those keys. This quote just perfectly captures the stakes. A single encryption key is such a tiny piece of data, but it holds this immense, almost unimaginable power. If it gets into the wrong hands, the entire fortress, it all just comes crashing down. So protecting these keys is absolutely everything. So how do the pros do it? Well, they follow this strict process called the key lifecycle. See, it's not enough to just create a key. You have to create it securely, distribute it without anyone seeing, store it somewhere safe, and never, ever right next to the data it protects. Then you have to replace it regularly to limit the damage if it's ever stolen. And finally, you have to completely destroy it when it's no longer needed. Every single one of these stages is vital. Now, managing a few keys for your own personal files is one thing, but what about a massive company like a bank or a tech giant that needs to manage millions or maybe even billions of keys? Well, that requires a completely different level of infrastructure. Let's start with the absolute bedrock of trust in this world, the Hardware Security Module, or HSM. I want you to think of this as a dedicated physical iron vault built just for your keys. It's a specialized computer whose only job in life is to generate, store, and use cryptographic keys. And the most important rule of an HSM is that the private keys never leave the device in a readable format. All the secret stuff happens inside its secure little boundary. And this is where it all becomes accessible for everyone. You don't have to go out and buy your own expensive HSM anymore. The major cloud providers, AWS, Azure, Google, they've all built their key management services, or KMS, on top of massive fleets of HSMs. They handle all the hardware, the key lifecycle, the auditing, and they give developers like us a simple, secure way to manage keys at an incredible scale. And really, this is the main takeaway for any modern development. The goal is to create a secure boundary. Your application, the code that you write, should never, ever handle a raw, unencrypted key. Instead, it just makes a simple request to the KMS, basically saying, hey, can you please encrypt this piece of data for me? The KMS does all the heavy lifting inside its secure vault and just hands back the scrambled result. The keys are never exposed. So, with all of this incredible technology, how do things still go so wrong? Well, let me tell you, the fortress almost never fails because someone breaks the lock. It fails because someone leaves the key under the doormat. And these are just the classic, heartbreaking mistakes you see all the time. A developer accidentally commits a secret key to a public code repository on GitHub, where automated bots find it in minutes. Or a company carefully encrypts its live database, but then stores all the backups, completely unencrypted, in a public storage bucket for anyone to find. Or maybe a key is just hard-coded directly into an application's source code, just sitting there. In every single one of these cases, the encryption was perfect. The key management, though, failed completely. So it all comes down to this, really. Every single secure service you use, from your bank to your messaging apps, is a digital fortress built on these very principles we've talked about. The math is solid, the locks are strong, but the ultimate security always comes down to one simple question: who is guarding the keys, and how well are they doing it?